Welcome to Sleepy Space Facts, where the wonders of the universe become calm bedtime stories. Tonight, we journey to Pluto, the tiny, frozen world orbiting at the edge of our solar system. Discover 100 peaceful astronomy facts about its surface, moons, and shimmering atmosphere, all told in a soothing rhythm to help you relax and drift off. Let the quiet beauty of Pluto's distant light carry you into deep, restful sleep. In 2015, there was an enormous wave of excitement across the space community. Up until that point, the best image humanity had of the Pluto system looked little more than a smudge in the darkness. Even the Hubble Space Telescope, with all its power, could only make out faint, blurry variations of color. Pluto was simply too small and far away for any real detail to be seen. But in 2015, everything changed. After a journey that lasted 9 long years, the New Horizons space probe finally reached Pluto. It flew by the distant dwarf planet and captured an astonishing level of detail and fidelity images unlike anything the world had ever seen. So, the question arose, what did the New Horizons probe actually see and discover during its flyby of the Pluto system? And what has it been doing since? My name is Alex McCone, and you're watching Astrum. Stay with me, and I'll guide you through the remarkable highlights of the New Horizons mission to Pluto and beyond. Let's begin with a little context. In case you're new to Pluto or it's simply been a while since you last heard about it, Pluto is a tiny, delicate world, much smaller than our own moon. It lies in the Kuiper Belt, a vast, diffuse ring of icy, comet-like and asteroid-like objects beyond the orbit of Neptune. Pluto was the last of the traditional 9 planets to be explored. This was largely because of its immense distance from us, but also because, for a long time, it wasn't considered particularly interesting. Hard to believe now, isn't it? Thankfully, the determined team behind New Horizons pushed for the mission to be approved, and in 2006, it was launched as part of NASA's New Frontiers program for medium-budget space exploration. The goal was simple but bold: to reach Pluto as quickly as possible. New Horizons was the fastest launch ever achieved. A lightweight spacecraft launched atop a fully boosted Atlas V rocket, the most powerful of its time. It sped past the moon just 9 hours after launch. To put that in perspective, the Apollo missions took 10 times as long. On its way to Pluto, New Horizons used Jupiter for a gravity assist. This clever maneuver shaved 3 years off the journey time. It also used that encounter as a kind of dress rehearsal, testing its instruments by capturing remarkable photos and videos of Jupiter and its moons. After this successful trial run, the spacecraft entered hibernation mode. This was to reduce wear and tear on its instruments during the long, cold journey. As 2015 approached, the mission team slowly began to wake New Horizons back up, reactivating its systems and preparing for the encounter. Each day, it sent back clearer, more detailed images of Pluto. For scientists and enthusiasts following the story, it was an exhilarating time. With every passing day, Pluto transformed from a blurry point of light into a world of astonishing complexity. Even before the closest approach, people could already make out a large heart-shaped feature on its surface. Then, on the 14th of July 2015, the probe made its closest pass only 12,500 kilometers from Pluto's surface. Mission Control didn't see the results immediately. However, during the flyby, New Horizons was far too busy collecting data and snapping hundreds of photographs to send anything back right away. When data transmission finally began, it was painfully slow just 1 kilobit per second. To make matters even slower, the signals had to travel across almost 5 billion kilometers, meaning a 4.5-hour delay between Earth and the spacecraft. But when the first images arrived, they were breathtaking. Towering mountains, sweeping plains of ice, vast glaciers, and even a thin atmosphere all revealed for the very first time. New Horizons also captured incredible views of Pluto's moons. Let's take a closer look at what it discovered. One of the first striking observations was Pluto's unusual relationship with its moons. Its largest moon, Charon, orbits very close and is surprisingly large relative to Pluto itself. Because of this, the center of gravity, the barycenter of the two bodies, doesn't lie within Pluto, but in the space between them. In other words, they orbit a point that exists outside of either object. Even more fascinating, both Pluto and Charon are tidally locked to one another. If you stood on one, the other would always remain fixed in the same spot in the sky, never rising or setting. That's incredibly rare. While many moons are tidally locked to their planets, it's almost unheard of for the planet to be locked to the moon as well. Visually, the two worlds are quite different. Charon is darker than Pluto, suggesting they may not have formed from the same material. Pluto's other moons are much smaller, only a few kilometers across. Their orbits are remarkably circular, and all lie in nearly the same plane as Pluto's orbit. Now, let's turn to Pluto's geology. Its most recognizable feature, the one that captivated the world, is the giant heart-shaped region, officially named Sputnik Planitia. Roughly the size of Texas, it stands out for its bright tone, which is due to it being a vast plain of nitrogen ice. Measurements revealed that 98% of Pluto's surface is covered in nitrogen ice, at an average surface temperature of 229 grados bajo cero. Water ice there would be hard and brittle, but nitrogen ice behaves more like water ice does on Earth, capable of flowing like glaciers along the edges of the heart. You can actually see these slow-moving nitrogen glaciers spilling into nearby craters and valleys. Across the plains are enormous polygonal patterns, vast convection cells formed as nitrogen ice slowly circulates beneath the surface. The absence of craters here suggests that Sputnik Planitia is geologically young, perhaps no more than 10 million years old, and is being continually renewed. This icy basin has puzzled scientists in many ways. Some believe it may have formed after a massive impact, filling with nitrogen ice that seeped upward from a possible subsurface ocean. The basin also creates what's called a positive gravitational anomaly, a region where gravity is slightly stronger than surrounding areas. Interestingly, Sputnik Planitia lies almost exactly opposite Charon, aligning with the system's tidal axis. The strong tidal interactions between the two could explain why Pluto and Charon remained forever locked in that cosmic dance. Surrounding the plains are rugged mountain ranges made of water ice, the only material strong enough to support peaks several kilometers high at Pluto's frigid temperatures. Among these peaks are potential cryovolcanoes, or ice volcanoes, that may have once erupted slurries of water and ammonia instead of molten rock. One such candidate is Right Mons, a massive 4-kilometer high dome with a large central depression. These cryovolcanoes may have played a role in reshaping Pluto's young surface. In another region called Tartarus, New Horizons revealed a landscape of towering ridges that resemble the texture of snakeskin or tree bark. These features rise up to 500 meters high and are thought to be penitentious sharp, blade-like ice formations formed through sublimation, where ice turns directly into gas. If that's true, Pluto is only the second place in the solar system, after Earth, where penitentes have been seen. On Earth, they appear only in rare, cold, high-altitude deserts, such as the Atacama in Chile. On Pluto, however, they are much larger and far more extensive, stretching across a vast region. Elsewhere, dark regions streak Pluto's surface. Most notably, the area known as Cthulhu Macula, vast dark expanse shaped somewhat like a whale. Unlike Sputnik Planitia, this area is heavily cratered, indicating an older surface. Some mountain peaks within it appear frosted with methane ice, which condenses more readily at higher elevations. The dark coloration comes from a substance called the lensa-tar-like material, made from hydrocarbons that have been altered by sunlight. Similar tholin deposits are also found on Saturn's moon, Iapetus, suggesting this process occurs throughout the outer solar system. Scientists had suspected the presence of tholins even before New Horizons arrived, but the distribution across Pluto's surface was puzzling. Why did some regions have thick coatings while others were nearly bare? Were these patterns ancient and stable, or were they actively changing with Pluto's climate? As it turns out, the tholins may be linked to Pluto's cryovolcanic activity. Pluto is one of the few known worlds where cryovolcanism is currently shaping the surface. When water mixed with ammonia and organic material erupts from beneath, it creates a slurry that spreads and freezes, forming new deposits. Observations show that tholins are mixed within these icy flows. Data from the Hubble telescope had hinted that Pluto was getting redder over time. New Horizons may have caught it during its reddest season, providing vital clues as to why. In a region called Viking Terra, scientists observed what looked like an eruption site where this reddish tholin-rich slurry had fountained outward, coating the terrain. Nearby, a crater and trough appear filled with the same material from an earlier eruption, showing clear signs of flow and pooling. In another area called Veril Fossae, New Horizons captured evidence of similar cryovolcanic flows, where that same reddish slurry seems to have moved down troughs and gathered in shallow basins. These strange deposits hinted at an active and changing Pluto, one that was far from the frozen, lifeless rock many had once imagined. But perhaps the most intriguing aspect of all is not found on Pluto itself, but on its companion, Charon. In enhanced color images of Charon, the first thing that stands out is the reddish cap covering its north pole. It is astonishing to think that this material may have come directly from Pluto. Because Pluto's gravity is weak, some of the tholin-rich matter ejected during eruptions can escape its pull entirely. This material then travels across space about 19,000 kilometers and settles onto Charon's surface. Since Pluto and Charon are tidally locked, they always show each other the same face. That means the same area of Charon is constantly exposed to this steady drizzle of particles from Pluto. Over millions of years, that process created the distinct red cap. Poetic in a way, Pluto, forever hiding its heart from Charon, while gifting it a mark of color in an endless cosmic waltz. Charon itself is a world of water ice, starkly different from Pluto's nitrogen-dominated surface. Its lack of volatile ices means it doesn't have a true atmosphere, whereas Pluto's nitrogen continually sublimates and refreezes depending on the seasons. Because of this, Pluto's atmosphere grows and shrinks dramatically over its 248-year orbit around the Sun. This process could even alter its appearance over time, changing its brightness and tone as ices migrate across the surface. For many people, one of the most awe-inspiring discoveries by New Horizons was confirmation that Pluto actually has an atmosphere, and not only that, but one of unexpected beauty. Due to Pluto's weak gravity, its atmosphere extends far higher above the surface than anyone anticipated. By contrast, Earth's thick and dense atmosphere clings close to the planet because our gravity is so much stronger. On Pluto, the atmospheric pressure is astonishingly lower, around 10 microbars, or between 100,000 and 1 million times weaker than that of Earth. Some models predict that at certain times in Pluto's long orbit, the pressure might rise to between 18 and 280 microbars, roughly 3 times the pressure on Mars, and a quarter of that on Earth. At certain points in its orbit, Pluto actually comes closer to the Sun than Neptune does. During those periods, the surface warms slightly, causing nitrogen ice to sublimate into gas and feed the atmosphere. Evidence of this sublimation is found all across the ice plains, yet the last time Pluto is thought to have had an atmosphere, as dense as Mars's was, about 900,000 years ago. Under certain conditions of pressure and temperature, liquid nitrogen could even exist briefly on Pluto's surface. Some scientists point to what looks like a frozen lake as possible evidence. Incredibly, within a single Pluto year, its atmospheric density can fluctuate by a factor of 4, a huge variation compared to other worlds that have atmospheres which remain relatively stable. This thin veil of gas is made up of the same materials found on the surface: nitrogen, methane, and carbon dioxide. But one of the biggest surprises was the discovery of up to 20 distinct haze layers within Pluto's atmosphere. Haze wasn't unexpected, but the sheer number of layers was. In photographs, these layers appear as delicate bands of mist stretching high above the surface, like faint curtains of fog. In one image, rays of sunlight pierce through a haze layer, casting shadows from the mountains below, a scene both eerie and breathtaking. Interestingly, these haze layers aren't evenly distributed. In some places, a haze band floats far above the ground, while in others it touches the surface itself. These are among the most stunning photographs of Pluto ever taken. They give a true sense of depth and scale, showing the icy mountains rising against a soft blue glow of scattered sunlight. Pluto almost looks like a tiny, handcrafted model, its rugged surface illuminated under a faraway sun. The mountains appear especially tall, not because they are enormous by Earth's standards, but because Pluto's gravity is too weak to pull them down into flatter shapes. Then, in June 2020, a group of scientists released a paper suggesting something extraordinary beneath. Pluto's frozen crust may lie an ocean of liquid water, much like those found on some of the icy moons orbiting the giant planets. For decades, scientists had assumed Pluto formed cold and had remained that way, given its distance from the Sun. But New Horizons data told a different story. It suggested that Pluto may have started hot, and that internal heat from radioactive decay or ancient impacts could have kept a subsurface ocean from freezing solid. If that's true, then Pluto might have maintained a liquid ocean for billions of years, raising fascinating questions about whether such hidden seas could be habitable. If Pluto is typical of dwarf planets in the Kuiper Belt, there could be countless other worlds out there with similar conditions. Evidence for Pluto's hot start comes from the surface itself. The planet shows signs of expansion rather than contraction, with long cracks and faults, indicating that the crust has stretched apart over time. If Pluto had cooled and shrunk, the surface would have folded instead. These observations suggest that as the internal ocean slowly froze, it expanded and pushed the crust outward. That realization paints a very different picture of how the outer solar system formed. Once thought to be inert and frozen, these distant worlds may have once been warm, dynamic, and possibly even habitable in their early days. Another fascinating detail from New Horizons data is just how few impact craters Pluto and Charon have. In places like Sputnik, Planitia, the surface appears almost completely unmarked by impacts, indicating youth and renewal. Even across the rest of Pluto and Charon, craters are fewer than expected. This could mean not only that their surfaces are geologically active, but also that the Kuiper belt itself might contain fewer small objects than once believed. When the flyby was over after only a few days, New Horizons continued on, heading deeper into the Kuiper belt. The spacecraft had traveled so far from Earth that even the nearest stars looked slightly shifted in its sky compared to ours. When it looked toward the Alpha Centauri system, the position of the stars appeared subtly different due to a phenomenon known as parallax. It's a humbling reminder of both how far New Horizons had journeyed and how unimaginably vast space really is. After the encounter, the probe barely slowed down. Its trajectory carried it ever farther from the sun, into a realm of darkness and ice where sunlight is faint and no human craft had ever gone before. But the mission team had a plan. They already knew of another possible target to explore. That next destination would become known as Arakoth. What made this target so special was that it hadn't even been discovered when New Horizons was launched. It would be found only later using the Hubble Space Telescope, and would become the most distant object ever visited by a spacecraft. The discovery of Arakoth was itself a remarkable story. In the year before New Horizons reached Pluto, the mission team was granted observing time with the Hubble Space Telescope to search for potential targets beyond Pluto that the probe could visit afterward. Hubble's powerful vision revealed 3 new objects located roughly along New Horizons' projected path. After careful study, one of these, a small body about 35 kilometers long, was chosen. It would later be officially named Arakoth. This made Arakoth a historic first, the only celestial body discovered after the launch of the spacecraft that would go on to visit it. After the successful Pluto flyby, New Horizons was still in excellent condition, with propellant left in its tanks and plenty of power remaining in its radioisotope generator. The team quickly sent commands to adjust its course for a rendezvous with this new mysterious object. At the time, Arakoth was so far away and so small that very little was known about it. Hubble could only measure its color and the variations in brightness as it rotated. Even so, scientists were able to gather some clues by observing Arakoth as it passed in front of a distant star, a process called an occultation. From those observations, they inferred its shape, which appeared to be elongated, possibly to bodies touching or orbiting very close together. Amazingly, their prediction turned out to be almost perfectly accurate. 3 years after leaving Pluto, in August 2018, New Horizons began its long-range approach toward Arakoth. At that time, it was still 172 million kilometers away, so distant that it appeared as nothing more than a faint point of light against a crowded background of stars. By December 2018, however, Arakoth had brightened in New Horizons' view, and the spacecraft began collecting its first sets of science data, traveling at a speed of 51,000 kilometers per hour. New Horizons was rapidly closing in. As the days passed, Arakoth's strange shape began to reveal itself. The images that trickled back showed an oddly flattened, lumpy object that appeared to consist of 2 connected lobes contact binary. It was relatively smooth, showing few signs of craters or major impacts. This alone was extraordinary. It looked unlike any asteroid or comet ever observed up close. Then, on the first day of 2019, New Horizons made its closest approach, just 3,500 kilometers from Arrokoth's surface. It was at this moment that the probe collected the bulk of its scientific data. This flyby made Arrokoth the most distant object ever visited by a spacecraft 6.5 billion kilometers from the Sun, about 45 times farther away than Earth. Because of the immense distance, the data connection between New Horizons and Earth was incredibly slow, only 1 kilobit per second. It's almost unbelievable that such a distant probe could communicate at all. Transmitting all the information it gathered around Arrokoth would take nearly 2 years. The mission team prioritized the most important data first, sending back the low-resolution images early so the world could see something of the encounter. But it would take much longer before the highest resolution pictures arrived. When they finally did, they were worth the wait. The images revealed Arrokoth in vivid, true color, soft reddish world bathed in faint sunlight. Unlike the grey asteroids found in the inner solar system, Arrokoth's hue came from a coating of tholins, the same kind of organic material found on Pluto and other icy bodies. Tholins form when simple compounds like methane and nitrogen are broken down by cosmic rays and sunlight, then recombine into complex, reddish organics. The spectra recorded by New Horizons showed that Arrokoth's surface contains methanol, hydrogen cyanide, and water ice. The abundance of methanol, in particular, likely contributes to its deep red color. Interestingly, scientists also detected an absorption feature at 1.8 micrometers in its spectroma, mysterious compound that remains unidentified. It's not something we've seen on any other known body. Without a physical sample, its nature can only be guessed. Another striking characteristic was the almost total absence of small impact craters. This was puzzling at first, but it may tell us something about the Kuiper belt itself. Although the belt could contain up to 200 times the mass of our asteroid belt, most of that mass is distributed among large, widely spaced objects like Pluto. Because the region is so vast, collisions are extremely rare, and when they do occur, they happen at much lower speeds. Here on Earth, meteors slam into our atmosphere at around 75 kilometers per second. In the Kuiper belt, by contrast, typical impact speeds are only about 300 meters per second. At such gentle velocities, two colliding objects might not even shatter, they could simply merge. Some of the depressions seen on Arrokoth's surface might not be craters at all, but sinkholes, formed when volatile materials beneath the crust escaped into space. This is part of what makes Arrokoth so special. It's a kind of time capsule, an untouched remnant from the dawn of the solar system. Because it has experienced so few impacts or disturbances, it preserves the conditions of the early solar nebula almost perfectly. In fact, Arrokoth's shape may itself be a clue to how the planets began. Rather than forming from a violent collision, the two lobes of Arrokoth may have grown side by side within the same cloud of icy material, slowly spiraling together until they made gentle contact. The speed of this merger must have been extraordinarily slow, more than 2 meters per second. The lack of fractures or stress marks where the lobes meet supports this theory. Both parts of Arrokoth even look remarkably similar in color and texture, suggesting they formed in the same region before merging, before receiving its official name. Arrokoth was nicknamed Ultima Thule, a term from ancient mythology meaning beyond the known world. The two lobes were dubbed Ultima and Thule, respectively, and you can still hear those names used informally today. Bright spots, certain areas of the surface. Some lie inside depressions that might have formed when material collapsed inward, creating small avalanches of bright, reflective ice. Another bright patch sits at the junction where the two lobes meet the neck. Scientists aren't entirely sure why this region is lighter in color. It might receive less sunlight, allowing volatile ices like ammonia to accumulate. Or it could be that loose surface material naturally rolls down toward this central low point. Gathering there over time, Arakoth is also incredibly lightweight, with a density of only about 0.5 grams per cubic centimeter half. That of water it must be porous and loosely packed. Over billions of years, volatile compounds likely seeped out from its interior due to residual internal heat, refreezing on the surface and leaving behind a more rocky framework inside. Surprisingly, models predicted Arakoth's temperature should be only around 12 to 14 kelvins, but New Horizons measured it at roughly 29 kelvins, still unimaginably cold, but warmer than expected. Perhaps the strangest discovery came later, when researchers analyzing the data noticed that Arakoth was much flatter than it first appeared. This wasn't immediately obvious because, during the flyby, the spacecraft's trajectory meant we were looking mostly down on it rather than from the side. Only when the data was carefully modeled did its true pancake-like shape become clear. Why is it so flat? The reason remains a mystery. It could be due to the way the two lobes originally formed. Perhaps they spun rapidly before merging, their rotation causing them to flatten. Another possibility is that over time, one side was exposed to sunlight for decades at a stretch, slowly evaporating away volatiles and changing its shape. Researchers continue to model these possibilities, trying to understand how such a delicate structure could have survived intact for billions of years. As New Horizons drifted away, it turned its cameras back one last time. Against the faint glow of distant stars, it captured a haunting silhouette of Arakotha, final glimpse of a world that no spacecraft may ever visit again. So what's next for New Horizons? The spacecraft still has power in its battery and about 11 kilograms of fuel remaining. Mission planners are now searching for any other potential targets along its path. Even if none are found, New Horizons will continue to journey outward, eventually crossing the boundary of the Sun's influencer heliospheres sometime in the 2030s, just as the Voyager probes did before it. Even if New Horizons never finds another Kuiper Belt object close enough for a third flyby, its mission is far from over. The team behind it has already submitted proposals for an extended phase that would transform the probe into a remote observatory from its unique vantage point beyond the planet's sit, could carry out astrophysical and heliospheric research impossible for any spacecraft closer to the Sun, because New Horizons is the only active spacecraft in the Kuiper Belt. It can provide data no other mission can. Future studies could include new observations of Uranus and Neptune, surveys of distant dwarf planets, searches for rogue black holes drifting through nearby space, and measurements of the faint ultraviolet and optical glow of extragalactic light. In essence, New Horizons would become our deep space eye peering outward from the solar frontier. Even before these plans are finalized, the mission has already delivered a treasure trove of discoveries. It gave us our first close look at Kuiper Belt objects and revealed how varied and dynamic they can be. No one expected Pluto to look the way it does: icy, colorful, and complex. with mountains taller than the Rockies and glaciers flowing across its plains. No one predicted that Coron would wear a red cap, or that Arakoth would be so oddly flattened and pristine. These revelations remind us how much we still have to learn about the frozen worlds beyond. Neptune, Pluto remains one of the most captivating members of our solar family. Yet even after everything New Horizons showed us, questions linger. People continue to wonder why Pluto is so dim and difficult to see from Earth when telescopes like Hubble can clearly image galaxies millions of light-years away. Others ask how New Horizons photos could be so well lit. Considering Pluto's vast distance from the Sun, these curiosities reveal our deep fascination with the edge of the solar system. So, let's explore some of the most common questions people have about Pluto. Questions that spark wonder and curiosity in equal measure. I'm Alex McCone, and you're watching Ask. Let's see if we can shed light on 4 of your top questions about Pluto each, with an answer that's as intriguing as it is enlightening. First question: how can Hubble see distant galaxies clearly, but not Pluto? At first glance, this seems to make no sense. Hubble has taken some of the most breathtaking images of distant space-vast galaxies glittering with billions of stars, millions of light-years away. Yet when it looks at Pluto, the results are blurry and unimpressive. How can Hubble reveal entire galaxies in stunning detail but struggle to capture a nearby dwarf planet in focus? The answer lies in something called angular diameter, the apparent size an object takes up in the sky. Take, for instance, this magnificent image of the Andromeda Galaxy. It's about 2 million light-years away from us. That distance might make you think it should appear tiny, almost invisible. But Andromeda is enormous, roughly 220,000 light-years across. Even from our distant vantage point, it still appears about 6 times larger than the full moon in our night sky. When Hubble photographs Andromeda, it can't even fit the whole thing in one frame. What we see as a single picture is actually a mosaic, a combination of hundreds of smaller images stitched together. The same applies to other nearby galaxies, such as the Pinwheel Galaxy, which lies 21 million light-years away but still spans almost half a degree in the sky, roughly the apparent size of the moon. These objects are vast, and even at unimaginable distances, they cover a noticeable area of the heavens. Now, compare that with Pluto. Despite being in our own solar system, Pluto is incredibly small and distant, so much so that its angular diameter is just 0.11 arcseconds at its closest approach to Earth. To put that into perspective, there are 60 arcminutes in 1 degree and 60 arcseconds in an arcminute. The moon's diameter, by comparison, is about 30 arc. So, Pluto's apparent size is more than 16,000 times smaller than the moon's. It's no wonder Hubble can barely resolve it at all. Larger planets closer to us like Jupiter or Saturn appear much bigger in the sky, allowing Hubble to capture their intricate cloud patterns and ring systems easily. But Pluto, tiny and far away, remains just at the edge of what even Hubble's optics can detect. That's why sending New Horizons to Pluto was so revolutionary. Before its arrival, no telescope, no matter how powerful, could show us more than a fuzzy blob. Every image from New Horizons was a revelation, a window into a world we had only guessed at before. Here's a simple analogy. Imagine standing in a garden. A small flower close to you represents Pluto, while tall buildings far in the distance represent galaxies. Even though the buildings are much farther away, their huge size means your eyes are a camera can still see their details clearly. The tiny flower nearby, on the other hand, may appear blurry if you can't focus closely enough. That's exactly the challenge Hubble faces when trying to image Pluto. Now, on to our second question. Why do Pluto and its moon Charon orbit around a point in empty space? Some people imagine this must mean something mysterious is lurking there, perhaps an invisible object like a small black hole. But there's nothing of the sort. What's actually happening is something every pair of orbiting bodies does. They circle their shared center of mass, called the barycenter. Picture a seesaw with two people of different weights. The heavier person has to sit closer to the middle for balance. In a similar way, if one body is much more massive than the other, the barycenter will be inside the larger body. That's the case with Earth and the Moon both orbit the barycenter. But because Earth is so much heavier, that point lies well beneath its surface. In the case of Pluto and Charon, however, the two are much closer in size and mass. That balance shifts the barycenter out into open space between them. So instead of one orbiting the other directly, both worlds swing around an invisible point between them. This isn't unique to Pluto. A similar effect occurs between the Sun and Jupiter, the solar system's largest planet, where their shared center of mass actually lies just outside the Sun's surface. But in the Pluto-Charon system, the effect is especially dramatic because their masses are so comparable. It gives the impression that they're dancing around an unseen center, locked in a gravitational embrace. Now, let's move on to the third question, one that many people ask when they see the dazzling photos sent back by New Horizons. How can Pluto's surface appear so bright and clear when it's so far from the Sun? Surely, it should be almost completely dark out there, shouldn't it? It's a fair question, and the truth might surprise you. With your naked eye, Pluto would indeed appear dimmer than the images show, but it wouldn't be nearly as dark as you might imagine. To help people understand this, NASA created something called Pluto time. Twice a day, during dawn and dusk on Earth, the amount of sunlight we receive matches what you'd experience standing on Pluto at high noon. During those few minutes, the world around you is softly lit with a twilight glow, the same gentle illumination that bathes Pluto's landscape beneath its distant sun. If you'd like to see it for yourself, NASA even made a website that tells you exactly when Pluto time happens in your area. During this period, you can step outside and notice that it's dim but still perfectly visible. Cameras and even smartphones can easily take photos or videos in that light. On average, Pluto receives about 1/1600th of the sunlight Earth gets. That means sunlight there is roughly equivalent to about 60 lumens per square meter, comparable to the light in a dimly lit corridor or stairwell. Of course, spacecraft cameras are designed to make the most of faint light. By using longer exposure times, keeping the camera's detector open for a few seconds, they can gather enough light to make even dimly lit surfaces visible in vivid detail. Astronomers do the same thing when photographing the night sky. With a long exposure, a camera can reveal the intricate structure of galaxies that the naked eye cannot see. So, when we see those bright, beautifully detailed photos of Pluto, they're not artificially lit. They're simply long exposure images, carefully processed to reveal what's really there. In essence, Pluto is dimmer than Earth, but it's not pitch black. The sunlight is weak, yet steady, enough for both the probes, cameras, and our imagination to paint the surface in soft, ethereal light. Now, for the final question, and perhaps the one that stirs the most emotion. Why isn't Pluto considered a planet anymore? It's a topic that still sparks passionate debate. For decades, Pluto held a cherished place as the 9th planet of our solar system. But in 2006, that changed, and for many people, it felt like an act of cosmic injustice. To understand why, we need to look at the history of how the term planet has evolved over time. Believe it or not, there was once a period when astronomers considered there to be over 100 planets in our solar system. The ancient Greeks recognized 5, beyond Earth, Mercury, Venus, Mars, Jupiter, and Saturn, and, for centuries, that list remained unchanged. Then, in 1781, the discovery of Uranus expanded our view, revealing that there were indeed planets beyond what the naked eye could see. Excitement grew, and soon after, more and more objects were found between Mars and Jupiter bodies we now know as asteroids, like Ceres, Vesta, Pallas, and Juno. At the time, though, these were all classified as planets. For a while, textbooks even listed dozens of them. It wasn't until the mid-1800s, when astronomers discovered how small and numerous these objects were, that they realized a new category was needed. Thus, the word asteroid was born, and the list of planets shrank once more. Then came Neptune, discovered in 1846, and a few decades later, the discovery of Pluto in 1930. At first, it was celebrated as the long-sought 9th planet. But as technology advanced, astronomers began to notice that Pluto didn't quite fit the mold. Its orbit was tilted and stretched compared to the others, crossing inside Neptune's path at times. And when better instruments measured its size, they found it was much smaller than expected, only 1/6 the mass of our moon. The real trouble began in the 1990s, when more worlds were discovered in the same distant region of space, known as the Kuiper Belt. Astronomers realized Pluto wasn't alone. It was just one of many icy bodies orbiting beyond Neptune. Some of these, like Eris, Sedna, and Haumea, were nearly the same size as Pluto or even slightly larger. Suddenly, the solar system seemed crowded again, just as it had when the asteroid belt was first discovered. Faced with this new reality, astronomers needed to define what a planet actually is. In 2006, the International Astronomical Union, the IAU, voted on an official definition. According to their criteria, for a celestial body to be considered a planet, it must satisfy 3 conditions. It must orbit the Sun. It must be massive enough for its own gravity to pull it into a nearly round shape. And it must have cleared its orbital neighborhood of other debris. Pluto easily meets the first. 2 conditions: it orbits the Sun, and it's round due to its own gravity. But it fails the third, because it shares its orbital zone with countless other Kuiper Belt objects. It hasn't cleared its neighborhood. For that reason, it was reclassified as a dwarf planet. Some people argue that this definition is unfair, since even the larger planets have smaller asteroids crossing their paths. But there's a difference between having a few stray objects nearby and existing in a full belt of other bodies. In Pluto's case, it's surrounded by thousands of neighbors. Rather than being demoted, you might think of Pluto as having become the ambassador for a new class of celestial objects, the dwarf planets. And interestingly, the redefinition had a silver lining. Ceres, which had been removed from the list of planets over a century earlier, was reclassified as a dwarf planet, too promoted from asteroid to something grander. So, while some still mourn Pluto's loss as the 9th planet, its new status doesn't diminish its wonder. Instead, it opened the door to a broader understanding of the solar system's diversity. We now know there are many worlds out there, like Pluto's more icy and mysterious siege, with stories of their own to tell. These 4 questions about Hubble's blurry images, Pluto's orbit with Charon, its brightness, and its reclassification help us see the dwarf planet in a richer light. For every mystery we solve, new ones arise, drawing us further into the beauty of exploration. Perhaps that's what makes Pluto so compelling. Like the mythical Hydra, every answer seems to grow new questions in its place. The more we learn, the more we realize how much is still unknown. But that's the essence of science, the thrill of discovery and the endless journey of understanding. If this story has sparked new questions in your mind about Pluto or the wider solar system, share them and keep exploring. Each mystery leads us closer to seeing the universe not just as a collection of distant worlds, but as a grand, unfolding story, one we're lucky enough to be a part of. This is Pluto, a strange, beautiful, and distant world where the sun shines like a bright star in the frozen sky. A place of mountains and plains, of nitrogen glaciers and winding canyons, resting on the far edge of the Kuiper Belt, a cosmic dream of color and ice. Pluto sits nearly 5 billion kilometers from Earth at its closest approach. A world so small and distant that for decades it remained little more than a mystery. Even with the Hubble Space Telescope, we could only make out vague smudges of color on its surface. But that changed forever in 2015 when NASA's New Horizons spacecraft arrived and sent back the first up-close photographs. Those images astonished the world. Veteran viewers of this channel may recall earlier videos about the New Horizons mission, but those were just glimpses of what this spacecraft revealed. Pluto, as it turns out, is far more complex, far more active, and far more beautiful than anyone dared to imagine. In today's story, we return to Pluto once more to explore what New Horizons found, what surprised scientists most, and how new research is transforming our understanding of this distant world. New Horizons launched in January 2006 from Cape Canaveral Air Force Station. Its mission was simple yet extraordinary: to photograph and study Pluto and its moons Styx, Nix, Kerberos, and Hydra. When it finally reached Pluto on July 14, 2015, after 9 years of travel, it captured a stunning view that left scientists in awe: a surface of mountains, plains, glaciers, and even signs of possible volcanoes. Because of the immense distance, though, the data came back slowly, just 1 to 2 kilobytes per second. It took 15 months for the complete dataset to reach Earth, and each new release from NASA sent ripples of excitement across the scientific community. Even now, looking at those images evokes a sense of wonder. There's so much detail, so much texture. Each picture feels like a puzzle piece, revealing a world that defied all expectations. Let's start with one of Pluto's most curious regions, an area near the equator nicknamed the Brass Knuckles. This striking chain consists of 6 dark lowlands, each roughly 480 kilometers, wide, about the size of Iceland. They stretch east to west like beads on a necklace and are separated by high, icy uplands. The individual regions have evocative names drawn from world mythology: Krun, Ayla, Balrog, Mengpio, and others. Fans of The Lord of the Rings might be delighted to know that Balrog Macula was indeed named after Tolkien's fiery demon of the deep. These lowlands get their dark tones from deposits of Tholin's organic compounds created when methane and nitrogen interact with ultraviolet light and cosmic rays. Tholins give Pluto many of its reddish-brown shades. You can see similar material in Cthulhu Macula, a massive whale-shaped dark region lying nearby. The brass knuckles appear distinct from one another because they're divided by towering uplands of ice. These icy ridges rise several kilometers high and are composed of frozen nitrogen, methane, and carbon monoxide layered atop a foundation of water ice. Water ice, at Pluto's temperatures, is as hard as rock, capable of forming mountains that stand firm against the dwarf planet's weak gravity. Softer ices like nitrogen, however, flow easily, pooling in the lowlands to form broad plains. Imagine standing at the base of those ice mountains, looking across canyons of frozen nitrogen, a landscape both alien and serene. Nitrogen ice dominates Pluto's surface, making up about 98% of it. In fact, the most famous feature on Pluto, the bright heart-shaped region, owes its appearance to vast stretches of frozen nitrogen. Officially named Tombor Regio, in honor of Pluto's discoverer Clyde Tombor, the heart consists of two lobes. The western one, known as Sputnik Planitia, is a smooth, icy basin. The eastern one is rougher, more textured. Together, they create a symbol of Pluto that captured hearts all around the world. The western lobe, Sputnik Planitia, is a deep basin filled with nitrogen ice. It gleams brightly in sunlight, contrasting sharply with the darker terrains around it. The eastern lobe, by contrast, looks mottled and pitted, like the peel of an orange. Scientists believe winds on Pluto carry nitrogen vapor from Sputnik Planitia up into the thin atmosphere, where it later settles as frost over the higher eastern terrain. This constant circulation gives the eastern uplands a high albedo, a reflective brightness, making them appear almost polished with frost. It's a fascinating cycle. Nitrogen sublimates from the plains, drifts through the atmosphere, and refreezes in the hills. The process is similar to a slow planetary heartbeat, endlessly transferring ice from one side of the heart to the other. Over time, some of that nitrogen flows back down the slopes in glaciers, completing the loop. Along the western edge of Sputnik Planitia rise the Elidrisi Mountains, an impressive range where winds sweep grains of methane ice toward the peaks, depositing them like sand dunes. What's astonishing is that Pluto's atmosphere is so thin, far thinner than Earth's, that scientists never expected it to be capable of transporting particles this way. But as nitrogen sublimates, it can loft tiny grains of methane high enough to settle elsewhere, creating vast fields of dunes stretching for nearly 2,000 kilometers. These dunes resemble those in deserts here on Earth, like the Taklamakan or Death Valley, except they form in temperatures near -230 degrees Celsius. The grains are so light and the gravity so weak that they would feel like soft dust falling through your fingers. Near the mountains, New Horizons spotted a deep trench running parallel to the peaks. On colorized elevation maps, it appears as a dark blue ribbon slicing through the landscape. The trench itself lies about 1 kilometer deep, and as you move away from it, the peaks climb even higher, some reaching 3 kilometers tall, roughly the height of the Rocky Mountains. Why does this matter? Because it may reveal what's happening beneath Pluto's icy crust. Recent research suggests that these towering mountains have migrated eastward through a process called solid-state convection, the slow churning of ice, behaving like a thick fluid over geological timescales. This movement may have formed the trench on the western side and lifted the terrain further east. If this theory is correct, then Pluto's surface isn't frozen in time, but actively reshaped by forces deep below, and this ties into one of the most intriguing ideas about Pluto, that beneath its crust might lie a vast subsurface ocean of liquid water. For such a small, cold world, this seems almost impossible. Yet evidence increasingly supports it. Similar to the icy moons Ganymede, Europa, and Enceladus, Pluto may retain enough internal heat, perhaps from radioactive decay, or the residual energy of its formation, to keep a layer of water from freezing completely. That possibility astonished scientists. For a body smaller than Earth's moon, to maintain an internal ocean defies old assumptions about where liquid water can exist. Evidence for this hidden sea also comes from signs of cryovolcanism. One such feature is Right Mons, a massive dome rising 4 kilometers high with a broad depression at its summit. New Horizons' higher resolution color images reveal it as a complex structure made mostly of water ice. The area around it shows remarkably few craters, suggesting recent resurfacing. Not far away lies another candidate volcano, Picard Mons, even taller at about 7 kilometers, though it was shrouded in darkness when the spacecraft passed, leaving its details faint. The shapes of these formations resemble volcanic calderas on Earth's sunken pits left after repeated eruptions and collapses. If they truly are cryovolcanoes, they must have spewed water and other ices instead of molten rock, adding to Pluto's landscape of icy renewal. The evidence isn't yet definitive, but as scientists often say, the mountain of data speaks volumes. Looking closely at the shapes of Right Mons and Picard Mons, scientists notice that both have wide circular depressions surrounded by concentric ridges, all most like the rings inside a tree trunk. This pattern might indicate that the volcanoes experienced multiple eruptions over long periods, each followed by the slow collapse of their icy vents. The result is a landscape unlike anything else in the solar system: enormous, frozen volcanoes rising from plains of nitrogen ice under the glow of a distant sun. What's truly striking about these regions is that they show no signs of heavy cratering. That suggests they formed recently, at least in geological terms, perhaps within the last few 100 million years. If true, that means Pluto remains geologically active even today, defying the expectation that such a small, frigid world should have gone cold billions of years ago. The presence of these possible cryovolcanoes adds strong support to the theory of a subsurface ocean. For such eruptions to occur, heat must still be escaping from Pluto's interior, forcing water and other materials upward through cracks in the crust. These icy plumes would refreeze on the surface, slowly rebuilding the terrain. It's astonishing to imagine that beneath Pluto's solid exterior may lie a deep ocean, kept warm by the faint afterglow of its formation. Beyond the heart-shaped plains and volcanic peaks, New Horizons also revealed an extraordinary network of ridges and troughs stretching across Pluto's mid-latitudes. One of the most unusual of these is a region called Tartarus Dorsa, covered in patterns that look like overlapping snake scales or bark from an ancient tree. These formations, hundreds of meters high, are thought to be massive penitenti spiky ice blades formed by sublimation, the process where ice turns directly into vapor. Here on Earth, penitentes appear only in rare conditions, in high, dry places such as the Andes or the Atacama Desert. Even then, they're just a few meters tall. On Pluto, however, they can tower half a kilometer high and extend for hundreds of kilometers, making them the largest penitentes ever observed anywhere in the solar system. Just imagine walking among the endless frozen spires glinting in the pale blue haze, under a sky where the sun is little more than a bright star dot Another fascinating region lies along Pluto's equator, chain of dark and light patches, sometimes referred to as the whale and the heart. The whale-shaped shadow is Cthulhu Macula, the same ancient terrain we mentioned earlier. It stretches nearly halfway around Pluto's equator, its surface blanketed with dark tholins that have been baked by sunlight for millions of years. Within Cthulhu's dark stretches lie scattered mountain ranges topped with bright methane frost, contrasting sharply with the reddish terrain below. This methane frost forms because temperatures at higher elevations are slightly cooler, allowing vapor to condense into thin, reflective layers. The interplay between the dark, tholin-covered plains and the bright, methane-capped peaks gives Pluto's surface a striking patchwork of color-deep red, soft gold, and almost white hues mingling in the sunlight. Everywhere New Horizons looked, it found surprises. The spacecraft even revealed that Pluto's atmosphere extends far higher above its surface than expected, forming up to 20 distinct layers of haze. Each layer scatters sunlight in subtle shades of blue, creating breathtaking scenes where mountains cast long shadows through the mist. The images of sunlight filtering through those hazy bands became some of the most iconic photographs ever taken in planetary exploration. From those images, scientists could see that Pluto's haze layers are uneven. In some areas, they hover far above the surface. In others, they dip down and seem to touch the ground. This suggests a complex interaction between surface winds, temperature variations, and sublimating ices. The overall effect is hauntingly beautiful. Pluto, wrapped in delicate veils of light, glowing softly against the blackness of space. Since the flyby, new research has continued to reshape what we know. In 2020, a team of scientists published evidence that Pluto's crust shows signs of expansion rather than contraction. This means its interior once contained more heat than previously thought, enough to keep its internal ocean from freezing completely. According to this hot start model, Pluto may have formed through energetic collisions in the early solar system, trapping heat inside its core. That warmth would have melted part of its interior, creating a global ocean that later froze outward, stretching the crust and leaving behind long fractures and rifts. Visible today, this revelation changes how we think about the Kuiper Belt. If Pluto formed hot, perhaps many other dwarf planets did too. Each might have once harbored oceans beneath their icy shells, and some may still retain liquid water even now. It suggests that the outer solar system, once considered cold and lifeless, could be far more dynamic and diverse than we imagined. And that possibility raises a profound question. If liquid water exists beneath Pluto's surface, could life, however simply, ever have emerged there? The thought seems improbable, but not impossible. Microbes on Earth thrive in places once thought too extreme, inside Antarctic ice, around hydrothermal vents, or buried deep underground. If Pluto's ocean contains the right chemistry, perhaps it too shelters tiny, resilient forms of life. Beyond scientific speculation, New Horizons also transformed our sense of perspective. After its encounter, the spacecraft looked back toward the stars, capturing views so distant that our sun appeared as just another bright point among countless others. From Pluto's vantage, Earth and its neighboring planets are invisible specks, lost in the glare. That image reminds us how vast space truly is, and how fragile our home world appears when seen from the edges of the sun's domain. When New Horizons passed Pluto in 2015, it barely slowed down at all. Its journey carried it deeper into the Kuiper Belt, toward regions no probe had ever explored. Years later, it would meet Arakoth, a quiet, ancient relic of the solar system's birth. Together, these two encounters, Pluto and Arakoth, have expanded our understanding of how planets form and how complex even the smallest worlds can be. The mission continues, though the spacecraft grows ever more distant. Signals from it now take more than 6 hours to reach Earth. Yet, as long as its power holds, New Horizons will keep sending back precious data whispers from the frontier of the solar system. Even today, nearly a decade after its flyby, New Horizons continues to operate flawlessly. The spacecraft, still speeding away from the Sun at about 51,000 kilometers per hour, remains one of humanity's fastest emissaries. Its instruments continue to collect valuable information about the Kuiper Belt, mysterious region filled with ancient icy remnants from the solar system's earliest days. Scientists are now using New Horizons as a kind of deep space observatory. From its unique position far beyond the orbit of Neptune, it can study cosmic rays, solar wind particles, and the faint glow of interstellar dust that fills the void between the stars. It's measuring the boundary of our Sun's influence, helping us understand the shape of the heliosphere and how our solar system interacts with the surrounding galaxy. Even though New Horizons may never fly past another object up close, it still has enough fuel to continue adjusting its orientation and sending back data for years to come. Engineers estimate that its nuclear power source, a radioisotope thermoelectric generator, will keep running until at least the late 2030s. After that, the power will slowly fade, and the spacecraft will drift silently through the darkness, its instruments asleep, but its journey endless. For now, though, New Horizons remains awake, listening, watching, and reporting from the frontier. Its achievements have forever changed how we see our solar system. Before 2015, Pluto was just a tiny speck on photographic plates. After New Horizons, it became a living world, a place of mountains, glaciers, valleys, and skies painted with faint blue haze. Its discoveries have forced us to rethink what's possible. Pluto showed that even small, distant worlds can be active and geologically diverse. It proved that planetary science doesn't end at the orbit of Neptune, and that the Kuiper Belt is far from a frozen graveyard. It's a dynamic region filled with secrets yet to be uncovered. And as for Pluto itself, it stands as a symbol of curiosity and perseverance. For generations, it was seen as an oddballer, lonely, demoted planet on the outskirts of our solar system. Yet the more we've learned, the more remarkable it has become. Beneath its icy crust may lie a hidden ocean. Across its plains, nitrogen ice flows like glaciers. In its thin atmosphere, sunlight scatters into soft blue rings. Every detail tells us that even in the coldest corners of the solar system, beauty and change still thrive. For the scientists who dedicated decades of their lives to this mission, New Horizons was more than a spacecraft, was a dream fulfilled. It reminded us what human ingenuity can achieve when curiosity leads the way. Every byte of data it sent back carried a message from the edge of the sun's light, that even the smallest worlds deserve to be seen, studied, and understood in the years since. Countless new generations of astronomers and explorers have been inspired by those images of Pluto's heart-shaped plain. To this day, it remains one of the most iconic symbols of exploration, testament to how far we've come, and how far we still have to go. So what lies ahead? New Horizons continues to transmit data as it coasts deeper into interstellar space. Mission planners are scanning the skies for any small objects that might lie in its path, hoping for one last flyby. But even if no new targets are found, the spacecraft's legacy is secure. Its instruments are still detecting dust from ancient comets, measuring the density of charged particles, and studying the cosmic background like the faint glow left over from stars that formed billions of years ago. Eventually, New Horizons will pass beyond the heliosphere, the invisible bubble created by the sun's magnetic field and solar wind. Once it crosses that threshold, it will enter true interstellar space, joining the Voyager probes in a quiet, eternal voyage between the stars. When that day comes, the spacecraft will carry with it a small plaque engraved with the words, "And images of humanity, a silent message drifting through the galaxy." Like a bottle cast into a cosmic sea, it will wander endlessly, long after its signal fades, and somewhere light years away, perhaps an intelligent being will one day find it and know that we were here thought. We looked up at the night sky, saw a faint point of light, and wondered what it was. That we built a fragile machine, sent it across the void, and turned a tiny dot into a world filled with mountains, valleys, and heart-shaped plains. Pluto may no longer hold the title of the 9th planet, but it holds something far greater, a place in our collective imagination. It reminds us that discovery is not just about what we find, but about the journey itself, the courage to venture into the unknown and to see beauty where others saw only darkness. In the end, New Horizons taught us a timeless lesson, that even the most distant corners of the solar system are worth exploring, and that wonder can be found in the coldest, quietest places if we only take the time to look. And so, as New Horizons sails onward into eternity, Pluto remains behind, silent, shimmering, and still turning beneath its pale blue sky, a frozen heart beating faintly at the edge of the sun's light, waiting for whatever explorers may one day follow. And so, the story of Pluto and New Horizons comes to rest at the farthest edges of our solar system, a story of distance, time, and quiet determination. Though the spacecraft now drifts through the endless night, its signal still whispers across billions of kilometers, carrying humanity's curiosity into the great beyond. When we think of Pluto now, we no longer imagine it as a distant, featureless rock, but as a living world, a place where ice can flow like water, where mountains rise under a dim sun, and where the air, though thin, glows with a delicate blue haze. The data New Horizons sent home changed Pluto forever in our minds. It transformed a mysterious dot into a landscape filled with valleys, plains, and endless wonder. Each of those discoveries was the product of human patience and ingenuity. The team behind New Horizons worked for decades, facing countless challenges, delays, funding struggles, the need for perfect timing to reach a target that moved faster than any other mission in history. Yet, when the moment came, everything worked flawlessly. The spacecraft soared past Pluto at more than 50,000 kilometers per hour, capturing images and measurements with astonishing precision. It was an achievement born from faith in science and the enduring human desire to explore. When the first clear image of Pluto arrived on Earth, it stunned the world. The heart-shaped plankton bore Regia seemed almost like a message, a symbol of affection from a world we had only just met. The scientists themselves were speechless, many moved to tears. It was as if the universe had quietly acknowledged the effort and sent back a gentle smile. Since then, New Horizons has reminded us of something profound, that even when a destination seems impossibly far, persistence can make the unreachable possible. Each photograph, each faint transmission, each scientific revelation was a victory not only for science, but for the spirit of exploration itself. Pluto, once the smallest and most forgotten of the planets, became the most poetic. It showed us that the edge of the solar system is not an ending, but a beginning, a place where new questions bloom like stars in the dark. What else lies beyond the Kuiper Belt? How many other frozen worlds hide beneath their icy crusts, waiting for sunlight and discovery? Perhaps one day, long after New Horizons has fallen silent, another mission will follow. It might orbit Pluto or land upon its surface, drilling into its icy crust to search for the ocean below. Or maybe it will explore the moon's Charon, Styx, Nix, Kerberos, and Hydreich 1, a fragment of this intricate, frozen dance. And when it does, it will carry with it the legacy of New Horizons, the pioneer that paved the way. For now, Pluto turns quietly under its pale sunlight. Each of its long years lasts 248 Earth years, and as it orbits, its atmosphere freezes and thaws in a rhythm as slow as time itself. Its faint winds glide over mountains of ice and through valleys carved by frozen nitrogen. Somewhere, sunlight still sparkles across the plains of Sputnik Planitia, reflecting faintly off the frozen heart that faces Coron, locked forever in a cosmic embrace. If you look up at the night sky and imagine where Pluto lies, you'll find it near the constellation Sagittarius, far beyond Neptune's path. Invisible to the naked eye, yet its presence is known. Its story carried by the light that once bounced off its icy surface and traveled for hours to reach us. In that sense, Pluto is both distant and near, a reminder that wonder is never truly out of reach. The next time you see a photograph of that tiny, glowing world, remember that it was once a mystery. Remember that people built a spacecraft no larger than a piano, sent it across 5 billion kilometers, and gave us the gift of seeing something no human had ever seen before. Remember that curiosity, persistence, and courage made it possible. New Horizons will continue to travel for millions of years, long after Earth has changed and civilizations have come and gone. It will carry with it the story of us, the story of a species that looked out into the darkness and decided to go there. So, as we say goodbye to New Horizons' journey through the Pluto system, we are left with a feeling that is both peaceful and inspiring. The mission may have completed its flyby, but its legacy endures in every classroom, in every telescope image, and in every person who looks up at the stars and wonders what else might be waiting to be discovered. This is the essence of exploration: to reach beyond what we know, to touch the unknown, and to bring back knowledge and beauty from the edges of possibility. In the silence of the Kuiper Belt, New Horizons still sails onward, carrying the echo of that heart-shaped world. Its signal grows fainter, its power wanes, but its message remains eternal. Even in the farthest darkness, there is light, and that light is curiosity. And so, beneath the distant sun, Pluto turns on, serene and slow. Its mountains glitter faintly in the frozen air. Its heart of nitrogen ice gleams in the twilight. It waits, patient and eternal, a small and shining world at the edge of everything we know. Far beyond Neptune's orbit, where sunlight fades into the quiet blackness of space, Pluto continues its endless path around the sun. Every rotation, every orbit is a reminder of how vast and resilient the cosmos truly is. Though no human has ever stood upon its surface, we intro, tonight I take you with me to Pluto. the icy dwarf planet beyond Neptune with a glowing blue haze and a heart-shaped plain that still amazes scientists. We travel far from the warmth of the sun, across frozen plains and mountains built of water ice. I'll tell you how Pluto was discovered, why it lost its planet title, and what NASA's New Horizons showed us when it flew by. Find a quiet place. Let your mind drift and join me for this calm journey to the edge of the solar system. Subscribe if you'd like more peaceful nights among the stars now. Know what it looks like thanks to New Horizons, and that knowledge has forever changed our connection to the universe. Intro to Discover Pluto and drift off to sleep with soft space facts. Travel to the icy heart of this dwarf planet. Explore its thin blue haze and the mysteries found by New Horizons. Pluto once stood as the 9th planet, but now rests in the Kuiper Belt with frozen nitrogen seas, tall water ice mountains, and maybe a hidden ocean deep below. We gently explore its discovery, the planet debate, and the science that still surprises astronomers today. If you enjoy calm space, stories, and quiet, cosmic journeys that help you rest, subscribe for more soothing explorations. If you close your eyes and imagine standing there, the view would be both strange and serene. The sky would be almost black, yet faintly tinted with blue near the horizon where sunlight scatters through thin layers of haze. The sun, no larger than a bright star, would cast long shadows across mountains of water, ice, and plains of frozen nitrogen. The silence would be absolute, broken only by the whisper of invisible winds moving grains of ice along the surface in the distance. Charon would hang motionless in the sky, its rugged, darkened face reflecting the faint light. Because Pluto and Charon are tidally locked, they always show the same sides to one another, eternally paired. It would be a hauntingly beautiful sight, a reminder that even in deep space, companionship exists. As you gaze upward, the stars would blaze more brightly than anywhere on Earth, without an atmosphere to blur them. Each would shimmer with steady brilliance. Among them would lie the distant constellations we know so well, Sagittarius, Capricorn, and the faint arc of the Milky Way. Somewhere in that glittering band would be the pale blue dot of Earth, invisible to the naked eye, yet home to every story, every dream, every mind that ever looked up and wondered. From that unimaginable distance, Earth would appear smaller than a grain of sand held at arm's length. Yet, from that same distant world, a spacecraft once came, a tiny machine built by human hands that crossed the void to send back images of icy plains, mountains, and valleys. That spacecraft, New Horizons, still drifts onward, carrying the hopes and questions of the species that made it. Its signal, faint and patient, travels through the dark at the speed of light, 5 hours to reach home. And every time those faint pulses arrive at a dish in the desert of New Mexico or the plains of Australia, they bring with them stories of what lies beyond the sun's farthest light. In time, New Horizons will fall silent, its generator exhausted, its instruments frozen. But its legacy will endure. The images it sent back will continue to inspire generations to come. Scientists will keep analyzing its data for decades, unlocking new insights about Pluto, its moons, and the distant Kuiper Belt. Pluto, once a symbol of loss when it was reclassified as a dwarf planet, has become a symbol of resilience instead. It reminds us that even when something seems diminished, its value can grow in ways we never expect. By losing its title as the 9th planet, Pluto gained something greater, a unique identity as the first known ambassador of a vast unexplored frontier. It stands as a monument to mystery, a reminder that not everything bright and beautiful lies close to the sun. Some wonders dwell in shadow, waiting patiently for the moment they're finally seen. And perhaps that's what makes Pluto so enchanting. It exists on the edge of everything, between the warmth of the sun's domain and the endless chill of interstellar space. It orbits in twilight, forever distant, yet somehow deeply familiar. It's the place where our curiosity meets the unknown and where science becomes poetry. As we reflect on New Horizons and all it revealed, we realize that exploration is not just about discovering new worlds, it's about rediscovering ourselves. Each mission, each glimpse into the cosmos, reminds us that we are part of something vast and interconnected. The same atoms that make up Pluto's frozen mountains once drifted through the same nebula that formed Earth, the Sun, and every living thing in that sense. Looking at Pluto is like looking into a mirror held by the universe itself, a mirror that reflects our own origins and our boundless capacity to wonder. So tonight, as you drift towards sleep, imagine the quiet stillness of that faraway world. Picture the soft blue haze around its horizon, the glitter of methane frost on its peaks, the slow dance of Pluto and Charon beneath the dim glow of a distant sun. Let the thought of it fill you with calm and awe, gentle reminder that even in the coldest corners of the cosmos, there is beauty beyond measure. And somewhere, far out there, a small spacecraft sails onward into the dark, carrying our dreams, our curiosity, and our light with it. Good night, Pluto.